Hello everyone. So today we are going to talk about virtualization and containerization. In the previous lecture, we have already talked about virtualization and we have understood the fundamental idea of virtualization, why it is needed, and what benefit that we can get out of this concept. So virtualization basically refers to a logical presence of anything. So nowadays virtualization is very common and we are using it frequently when we talk about cloud computing. So the entire idea is based on the virtualization where we are able to run our entire data center onto the clouds. So we don't have any physical data center, we don't have any physical computing devices that we use to operate our business, but everything will be deployed onto the computers, and we are uh, very easily managing all the things using our computers with the help of browsers. Everything's are going to manage. So this is virtualization. Already we have discussed that why actually it is needed, and then also we have talked about Docker, which is basically providing us the containerization. So in this session we are going to see that what exactly is the Docker and how to make use of that, and just have a quick understanding of these virtualization and containerization. So let's see. So virtualization basically is here we are trying to virtualize the physical hardware. So we have hardware given to us. So hardware is always required when you want to, when you say any computer. So computer is a kind of a physical hardware, and at the top of it we can install operating system, and then we can run the application. So we have our computer, we are calling it as a physical hardware, and on the top of physical hardware we are installing a software we are calling as a hypervisor. Now this is the key thing that virtualize our hardware. So when I say virtualizing the hardware, that means we are trying to represent one single hardware. So let's say this is your one machine. This is something, the scenario. We have this one machine, one computer is there, and now we want to virtualize this computer so that this computer can take many shapes. So now we can virtualize it, and now this computer can be appeared as three computers or four computers. So now with the help of virtualization, we are able to represent the entire computing capacity of this single hardware and divide it into multiple virtual identities, which actually appears as independent, though they are actually not independent, but it appears while working on this machine, it appears that these are independent. So this is only possible with the help of hypervisor. So hypervisor is a kind of software that makes virtualization possible. And our objective is to virtualize the hardware. So when we talk about hypervisor and virtualization, so here we are virtualizing the hardware. Later we'll see that when we talk about containers, in that case we are virtualizing the operating system. So why we move to the containers, why we talk about Dockers, that is very important to understand. So we can understand in this scenario. So just have a look. This is our physical system. So physical system is comprising of all the computing resources that is provided within the system. That is, we are provided with processors, memory is there, and then we have input, output, storage is there. Now all these resources is actually required to make use of any computing device. So this is physical system which is given to us. So when I say processor, maybe I have a desktop, I have a machine, I have a computer, and I am using the processor of Intel family. Let's say I am using Core i10 processor of let's say 10th generation, and I am having a memory. The RAM I have given, let's say 8 GB RAM is there, and also I have 200 TB hard disk, or let's say 2 TB hard disk is given to me. Now this is my configuration, and I am running one OS. So basically, if there is no virtualization, then the OS is basically the entire administrator who control all the processes. And whenever anything to be executed on this machine, then OS will actually guide that how to provide these resources so that application can execute. But now, when I am using the virtualization, then I will be installing the layer at the top of physical system, that is on my hardware, and we are calling it as hypervisor. And with the hypervisor, I am able to virtualize my hardware. And what does it mean? It means now I can distribute my entire capacity into multiple machines. So I will create one machine here. I'm calling it as a virtual machine. So this is virtual machine one, and then I will assign the computing powers. I will assign the processing capacity, the memory, the virtual storage, and on this machine I can run any application that I want to use on this. So the advantage that we see here is that here, if there is no hypervisor, then on this machine I can have only one operating system, and entire thing is governed by this operating system. But now with the help of hypervisor, what I did is I am able to install as many operating system on the top of this. So this is hypervisor. Now I can run different operating system and can do my task. So if you look to this figure, so this is our hardware, and then at the top of this we have hypervisor, and then on the top of this we have different operating system installed, and these operating system can work independently. So actually these machines are now independent. They have their independent computing resources. Whatever the memory assigned to this machine is not shared by this. So for example, let's say we have here 8 GB RAM is given. So in our hardware we have 8 GB RAM. So out of 8 GB, let's say I have distributed 1 GB RAM to this machine, 1 GB RAM to this machine, 1 GB to this, and so 3 GB we have given here, 2 GB here, so 3 plus 2 5, and then also 2 GB we are given here. So this is how we can distribute the entire capacity. Similarly, if we have, let's say 100 GB hard disk is given to us, so then we can also distribute this 100 GB among these. Now once we have divided the entire capacity among these machines, then they will be given to its in full. That means even if this machine is not working, then the capacity which I have assigned here will not be utilized by any other machine. So for example, let's say in terms of capacity of 100 GB, let's say 20 GB is given here, 20 GB is given here, 20 GB is here, 20 here, 20 here. So now this entire capacity we have divided into these five virtual machines, and they are now acting as an independent machine, and they will retain its computing power all the time. What does that mean? It means if if this needs if this machine needs more than 20 GB for storage, or let's say this machine needs more than 2 GB RAM to do it execution, then it's not possible, because these machines are fully independent and they cannot share the resources. Now this is something which we have realized, this foundation we have realized, and now we move to one more layer above to virtualization. So when we talk about containerization, when we talk about Docker, that means we have moved beyond virtualization. We want to make use of all the resources in a more efficient way. Though we have realized here that the resources are kind of managed in a better way, because we are able to distribute the entire capacity into different machines, and now all these machines are actually working on one hardware, but it gives a feeling that there are five different machines are running. But still we are bound with the division, and these division means the entire capacity which is we are having cannot be distributed all the time. So let's see how we can overcome this kind of limitation. So let's move to the next part. So here we have a Docker. So Docker basically is the name of the company, but in general we use the concept of virtualization of container as a Docker. So the actual container that is provided by the Docker is a Docker engine. So here we have a Docker engine that basically is the founding idea that provides the entire thing of containerization. Now, what is containers and why they are very very popular nowadays? So let's understand what exactly is the container. So we have seen that we have hardware. At the top of hardware we have the hypervisor, and at the top of hypervisor we are creating the virtual machines. This is what we have seen in the virtualization, and then we are calling, as we have virtualized the hardware, that instead of calling it as one hardware, we are able to virtualize into a different form, and what we did is we have distributed. So now this machine itself is a complete a computer, or having a complete identity. Now this will install its own operating system. So let's say this is a window machine, this is also window machine, and it will install its own operating system. So when you install operating system itself will take a lot of capacity. For example, if you are running your Windows system on a laptop, you may realize that it may take somewhere uh, uh, 4 GB of space for for the installation itself, any machine. So it will take like 3 to 4 GB for its installation. Along with that, it will also will take some memory as a RAM memory for its execution. So these devices are independent and will also occupy space for the installation of OS. Means the entire OS will be installed in this machine. The entire OS will install in this machine. All machine will have their OS installed independently. So that means it will require the space, like 4 GB we have said. Similarly, they also will require some MB of RAM to get this task done. So when we distribute the RAM, for example, we have, these are like maybe we have our kind of big capacity hardware, and then we have allocated, let's say we have allocated 2 GB of RAM here, 2 GB of RAM here, 2 GB of RAM here, and 2 GB of RAM here, and we are assuming that we are provided with 10 GB RAM. Now this 10 GB RAM has been distributed among these four devices. So if this device needs more GB to execute any of its application, then it is not possible, because we have only 2 GB provided here. Even if you have like created one more virtual machine, and then if you have used 2 GB, that means the entire 10 GB we have used here, and now we are not able to create a new virtual machine because we are out of the the capacity. Now think in a scenario that we want a flexibility, that if any of the machines are not utilizing this full capacity, means this full 2 GB, then it can be shared among themselves. So for example, though we have created these machines, but if this machine is not like functional or operational, it is not actually executing anything here, so this 2 GB is not utilized here. So if other machine may be needing some capacity, then it will be supplied to the other. That means whatever the capacity is provided with this hardware should be shared among these virtual machine. This is what actually we are looking for, which is not possible in virtualization. Now this is we are able to achieve with the concept of Docker. So these, here in the case of Docker, when we have a hardware, and at the top of hardware we have operating system, and at the top of operating system we have a Docker engine, and at the top of Docker engine we have our containers. So if you look to this structure, in this structure what we have seen, we have the hardware, we have the hypervisor, and then we have our virtual machines. But now here we have operating system, we have a Docker engine, and we have our containers here. So now these containers, how they're different from these virtual machines. So here, when we say container, so container is basically an entity which will complete in itself. So here, whenever you create a container, it will not occupy the entire hardware capacity, but whenever anything to be executed, it will just refer to this OS, and then from this OS it will take the capacity, do the execution, and then when this is not executing, not in use, then this capacity will be released and can be available to the other containers. So that means whatever the capacity this OS is having, so when I say this OS is having, means the entire capacity is available here. So if this is 10 GB, then this 10 GB is not assigned fully to this container. Means if this container requires 2 GB, then at any point of time it will be given to 2 GB here, and when this task is done, then this 2 GB is released, and this is available for other containers to utilize and get its work done. This is how the things are working, and we are able to utilize our resources in a better way. Now these containers are actually not installing the OS, but so actually in the real sense they have a very small copy of the OS to get their tasks done, but actually they simply refer to the host operating system on which they are installed. They simply refer to the host operating system, get the necessary resources to get their work done. And when I say resources, means they simply get the computing power that is required to get their work done. Otherwise, to run the application, this containers is completely independent, which contains the entire kind of package that consists of all the dependencies, all the libraries which is required to run, to execute any application. So all containers are fully independent in itself, because it is providing a fully executable environment by keeping all the dependencies and library for any application to execute. And because they don't have this OS installed, so all containers do not have their own OS installed, so they do not keep uh, static, means fixed memory with them all the time. That's why they're also said to be a very lightweight package, because the OS is not installed. They can simply be deployed on the top of any Docker engine, and Docker engine will take care to execute any of these applications which are running on these containers. So this is the beauty of the container, and you may realize that this is having much better advantage than virtual machine. So if we differentiate virtual machine and Docker, we can say that virtual machine is basically virtualizing the hardware. So we can say uh, in virtualization we are virtualizing the hardware, but containerization in the containerization we are virtualizing the operating system. This is what we are actually doing in both the concept, and here we are getting far better flexibility in context of this virtualization concept. Also, one thing to be noted here, that when I say that OS has been not installed, so now they are like independent kind of containers. They are like entities which can run on any operating system. So it's not mandatory that if Windows is installed here, then they have to be all Window machine. This can be any. So if you want to install Linux, then you can install Linux here, and it will just uh, take all the required files and setup from the registry. So the entire environment works together with the registry and the Docker engine. So Docker engine is also known as a Docker daemon, which is basically the key element which makes the entire system to work. So Docker engine will take the request from the client who is writing the commands onto the from the host, means the one who is using the machine, the one who want to send any command. So from the client, this command has been written or given, and it goes to the Docker engine. The Docker engine will look to the command and will find out if something is needed and to be done. It will refer to the Docker hub. So we'll see what exactly is the Docker hub now. Okay, so before looking to the Docker Hub, let's have a very quick comparison between virtual machine and the Docker. So in terms of memory usage, definitely this virtual machine will consume more memory because it will create its own independent operating system, and it will use memory which will be remain fixed throughout the lifetime of that virtual machine. But here, memory usage is actually very less. Performance wise, if you compare both the two, then Docker is having a better performance, and they are very lightweight. It can be portable from one environment to other environment without caring for anything, because uh, this container provides the complete environment. uh, so the best part of this is because this environment is possible to provide at all the time, so it will help the people who are developing the software, the one who are testing the software, and one who are actually into the production. So at the time of development, they can use the same environment inside the container, and can see that how the application performs, behave. And similarly, at the time of testing, the same container environment will be provided to the team, so they can just realize and check with the various test oracles. And similarly, at the time of production, the same environment will be there, so there is no kind of discrepancy. Normally, without the containerization, without the concept of containers, there may be sometimes having a discrepancy, because at the time of development, whatever the environment they have used, they may have observed or have a different experience they have realized at the time of development. At the time of testing, they may have a different environment when they are testing the application. So they may have some differences in the output, in the performance of the application, because environment on which the application is running is different. But now, with the help of containerization, they may be able to use the same environment which actually to be used uh, at the production finally. So now this kind of problem is now being resolved. So and as a performance wise, this is far better than the virtual machine, because we have find this kind of portability uh, in the Docker. And then boot up time, they are very lightweight, so it will initiate kind of initialize very fast. But when we talk about virtual machine, this is a full operating system, so it will take the normal time to boot up like any machines will take. But with this, because they are very light, they don't have all these stuff, so it can be very fastly initialized and will get to work. So here, just have a quick look that how the memory has been utilized in the two different scenarios. So as we said, that it creates its own operating system. So whatever the uh, capacities assigned to the operating system will be remain fixed with them. But here, at all the time, whatever is actually utilized will be engaged, but whatever is not utilized will be taken as a free and provided to any other container or an application which actually needs this kind of capacity to execute or to work on. So now, looking to the components of Docker, so we have four components basically. We have client and server, we have a Docker image, registry, and container. So these are the main components on which the entire concept of actually the Docker works. Along with that, we also actually talk about Docker ecosystem. So Docker ecosystem is comprising of all the tools and packages that is available with the Docker to run your application. So we have Docker Compose is there, Docker Swarm is there, Docker Desktop is there, Docker Dashboard is there, and all these tools and packages work together to make the entire development process, deployment process, maintaining process of any software become so easy and very manageable for all the developers and the testers. So client is basically the one who is uh, writing commands onto the host machine, and then server actually referring to the Docker engine. So Docker engine, so you can see this is a client which will be writing the request or sending the request, and it goes to the Docker daemon, which is basically uh, Docker engine, which takes the request, and then if something is needed, then it will just consult to the Docker registry. So Docker registry is basically a repository. So in this Docker ecosystem, we have a repository, and this repository will it actually contains uh, thousands of information. The data, it's a open source, so everything which is required to execute an application is actually applicable, is available there. So every time when the sender sends a request, the required thing is to be fetched from Docker registry. For example, if the container wants if you wants to create a container that needs a Linux based system, so it will simply this will go to the Docker engine. Now Docker engine will see that the Linux need to be installed here, so it will just fetch the image. So it will fetch the image of the Linux machine, and then will be deployed on this container. So everything which is required to run the application is actually applicable, is available in this repository. So this repository is a huge kind of collection of the libraries, of the dependencies which is needed to run any application. So we have two kind of registries are there. We have a public registry, we have a private registry. So we'll see, let's move to the next part. Then we have something called Docker image. So Docker image is basically a template. It's a read-only file. So you can have a look here. These are some instructions are mentioned here. These are only read-only. You are not allowed to change here. So these instructions are given here, and so this is basically an image is basically a set of instructions which help you to create the container. So our objective is to create the container, right? So how to create the containers? This can be created with the help of Docker image. So if you want to create a Linux machine or a container which actually runs on a Linux environment or on a Unix environment or on a Windows environment, so you will send the request to the daemon, and then the server will fetch the required image from the repository, and then will install. So it will install one by one command. So it's a kind of first command will be executed, and then second instruction will be executed, third will be executed, and then fourth will be executed. So container is being developed uh, based on this command. So it's a kind of layers, means it will create the first layer, second layer, third layer, fourth layer. For example, when you construct any multiple story building, so you will just create the first kind of floor, and then on the top of it you will again second floor, third floor, and fourth floor, and so on. Similarly, it will create the entire containers in the form of layers. So all the command be executed and will give the foundation to the next layer, and the next layer will give the foundation to the third layer and fourth layer, and so on. And finally you get your container ready to get your application executing on this environment. And these templates are written using YAML, this is called yet another markup language. And then we have a Docker registry. So Docker registry, as I said, it's a repository that will hold all the required thing. It's a huge library, you can say, which is a container of many kind of images that will be used to create your containers. Now we have two kind of registries are there, a public and private. So like when I say Docker Hub, so Docker Hub is a public accessible registry, where anyone can see all the images, can use the images, and can construct their containers. But the companies may also want to have the private registry, the private repository, where they want that only their employees can have access to these images and can get their work done. Because this is for sure that registry maybe is actually definitely for read. It means to run this concept we need a repository, because everything's to be fetched from the repository. Either it may be a public or private, that is a different thing. So if it's a private repository, then it will be authentication based. Only the employees of that organization may have some credentials to access the private repository, and then all the stuff is only visible to that organization who are actually using the private. And the public is something which is accessible to everyone, available to everyone. So Docker Hub is one of the public registry, but there is an option provided by the Docker that you can pay to the Docker and you can also create or private registry. So finally, we have a Docker container. So Docker container is a kind of, it's a executable package of application and its dependencies built together. So container is itself entirely complete by keeping all the dependencies uh, and the executable stuff which is needed to run any application. So it gives all the instruction for solution to run. It's very lightweight and can be portable from one environment to another without caring for anything. And they are lightweight because they don't install OS within itself, and they are completely run in isolation. They are fully independent and does not affected by the other containers running on the top of the same hardware. For example, if this is the hardware one machine and there are many containers are running, so something goes wrong with one container is not going to affect all these containers because they are fully independent and isolated. So the memory of the Docker environment can be shared. So RAM is always a very important kind of computing resource to keep all this execution. And now we are able to utilize this RAM uniformly with all the containers, all these virtual machines. So this is actually, again, these are virtualized machine. Definitely they are also virtualized, but we are virtualizing the operating system in place of hardware. What the virtualization concept is entirely different. So if you want to run these images onto the container, we have a run command. So I have just written here one command, but there is a series of commands are actually required when we work with these containers. So to construct a Docker container, so means if you want to develop a container, you need to call the image file. Okay, so whatever type of container you want to create, you need to call the image file from the repository, and then the daemon will execute all the layers that is given in the image. So image means it's a set of command, all the commands be executed, and then once all the commands will be executed as a uh, in the form of layers over the other, and finally your container is ready. So uh, let's say there is one image, let's say Redis, with the name Redis is there, and you want to run this Redis container. So you want to employ this OS into the virtual environment. So you will say docker run redis. Now this redis to be fetched from the repository, and then it will execute all the instructions given on the image, and your container is ready. So how to create this image file? So image file can be created by using a docker file. So docker file is one mechanism through which you can also create your own instructions. Otherwise, for most of the time, we have already ready-made entire environment is provided to us in the form of images. So we just need to look what kind of image is good for our usage. We can simply fetch from the repository. But if you want to create something based on your requirement, you can also create these images using a docker file, and then you can push these images, means you can save these images into the registry, so that anyone can access, means wherever you are using the containers, the entire team is using the container, they can simply fetch that file from this public registry and can get their work done. So I hope now you have understood what exactly is virtualization, what is containerization, and how the containerization is better than virtualization, and what is actually the Docker. So Docker is basically the name of the company, and that bring us this concept of containerization. And normally when we talk about containerization, we are simply calling it as a Docker. But Docker itself is a full ecosystem that provides so many things to handle the entire stuff which is needed to run, execute, deploy this containerization. So this is because very fundamental idea, very general things to discuss here. So I have not discussed the entire ecosystem here, but I hope that this is sufficient for you to have an understanding about these important concept which is used nowadays in cloud computing. So as a student, or uh, being studying this cloud computing, you must be in a position to know what are these terms, and what does terms has a significance. So this is all here, and now we will see that how to make use of Docker to really come out with some some tangible things. So here I am stopping this video, and then we'll continue in the next part. Thank you.